In the news now, ITNN 2020. Slowtech Inc.'s off-energy micro power test 1, adding a second prime mover. Brought to you by ITNN, reporting on regenerative energy, a new type of renewable technology. I'm the architectural industrial inventor. My name is Gerald E. Bickham Picard. In this upcoming video, you'll see how adding a second prime mover actually reduces its charging power as well as increasing its capacity to charge the battery bank. Please understand its internal power is 5,760 watts. Generator output energy is about 1,400 watts, a total of 7,100 watts thereabouts. Understand its internal energy also powers the prime movers as well as the electronics and the generator. Therefore, part of its internal energy can be used to power facilities if large enough.
Coming off the grid, going to the main strip, right there.
This 24 volt system is using 62 watts to power 5,700 watts.
And over here, we have grid power switch 1 going to internal. We have grid power switch 2, NOCO, is going grid power instead of internal. And prime mover 2 is turned off, so we're running on one prime mover only. And here are the battery readings. Right there. We're going to turn on the RPM to record. These are where our batteries are at the moment. Inverter 1, inverter 3, power coming in. Right. We're going to power the machine up. Let it run here at 100 volts to start with. Brushes and complicators will be replaced with a production model, which will have brushless system. It will be running off of a computer. Right now we're at 560, 570 RPM. It's the energy coming out of generator 1. It's energy going into motor 2. These are what the variac powers are reading. Here is the battery. You can see the voltage. And now we're going to pick this up to about 120. And you notice how it's smoothed out quite well. Let's look and see what our wattage is. These are what the wattage is for the NOCO.
It's used to charge its internal power source.
The variac is running off the internal energy, which is coming off of the inverter 1.
Internal power inverter.
As you can see, switch 1 variac is in internal energy. Here's where the batteries are at. Here's where our RPMs are. And there's generator 1, motor 2.
Generator 1 uses inverter 4.
This is the energy going to each of the inverters that we're running. We want to look at that a little bit more right there. Alright, we're going to switch on prime mover 2 right here. And check out the energy. Look at that. That is prime mover 2.
Multiplying generators volts and amps gives watts.
That is the energy coming out of the generator.
Generator 1 watts is now 1,200.
These are the volts, the volts going into inverters. DC. There is our battery.
Battery went down to 24.75 volts, but it will increase later.
This is our wattage. Variac, of course, is internal. It has 0. NOCO.
Charging energy is now reduced.
398 watts. Off the grid. Again. There she is, off the grid. 113, we're going to pick her up a little bit more to 120.
Variac that operates the prime movers comes from its internal power source.
Alright, we're at 120. As I said, brushes will be going to brushless on the production model. RPMs.
Generator 1, 242 times 6 amps equals 1,452 watts.
As you can see, the voltage is going up some.
Grid energy used to charge the battery bank via the NOCO charger remains the same, all while the machine is under load and powering 2 prime movers. The battery bank will actually increase its energy.
Alright, we're going to turn on inverter 3.
Inverter 3 is connected to its internal power source, 5,700 watts.
And we're going to plug in some lights.
Internal energy is now powering the prime movers and a load.
Inverter 3 is on.
Also the generator 1.
And these are 100 watt light bulbs.
Internal energy can also power other devices.
That's the first one. 200 watts.
Over time, without affecting the NOCO charger, battery energy will increase slowly.
That's the battery rating on the Firefly. RPM.
RPM will decrease but will eventually rise.
We're still at 100 watts, 120 volts. There's a wattage from the NOCO coming off the wall. 392 watts.
Once the device harmonizes, charging energy will begin to decrease.
300 watts now. 400 watts of energy. Each bulb is 100 watts each. At 400 watts. This is the battery rating.
The watts for the charger will remain the same, but the energy will increase in the batteries.
RPM.
Actually, the RPMs will increase also.
Generator 1 produces 240 volts at 5.9 amps.
From 1,200 it went to 1,400 watts.
It's the energy coming out, going to the inverters. Running off, the machine is running off of inverter 1. The lights are running off of inverter 3.
Inverter 3 uses 58 watts to power 400 watts of lights. That leaves 5,105 watts left of internal energy.
392 volts, or 392 watts coming off of the grid, right there.
Increasing the Variac to 130 volts
Nowhere else.
will reduce the amount of energy required to charge its internal power source.
Our RPM, and our battery.
The 5,560 watts of internal energy is now powering 543 watt load, 2 prime movers, and a 1,400 watt generator.
Running off the Fireflies, 12 volts each at 116 amps. Each one is 116 amps at 12 volts each.
RPM has increased. The energy from the generator is now over 1,498 watts, while all under a load. As you can see, the energy from the grid has now went down to 382 watts as we increase the Variac to 130 volts.
Cord coming off the grid. Running only the NOCO.
Battery charger.
This is the internal light power that our LEDs are running up here. That is what's going into the NOCO charger, which are charging these batteries.
Understand it's also powering a 1,400 watt generator.
That's 400 watts. 12 volts each, 116 amps each.
5,568 watts.
As you can see, the battery is going up.
What is strange is that the energy from the grid to charge the battery bank is going down.
RPMs appear to be going up.
Generator is now 1,488 usable watts. Just incredible, really remarkable.
So we are at 134 volts coming off the Variac now.
To sum it all up, the energy from the grid is only using charging apparatus, charging the internal power source of 5,700 watts. Its internal power, based on the Variac at 130 volts, it's using less energy from the grid, yet it's powering a generator of 1,488 watts plus 400 watt light bulbs. Being another prime mover should make it even more efficient, I would say.
And of course, there's the cord going to the lights. Right here.
By increasing this 24 volt system to 11,000 watts of internal power, as well as changing the Variac to 230 volts, we should easily get up to 14,000 watts of usable energy. There you have it. Off energy micro power can power residents as well as reverse the grid, reducing its return on investment down to a year by just leasing the technology.
These will become brushless, which will create actually even more energy.
Totally off the grid, have the NOCO charger tap into renewable energy, solar and wind turbines.
Thank you very much. I hope you enjoyed.
OEMP utilizes multiple prime mover technology. This 16-pole 4 prime mover production CAD image, equivalent to about 12 horsepower. Our 4 prime mover 16-pole CAD-CAM model, powering a 60,000 kilowatt cog-free generator. Be 2 models. OEMP Power can power your house with its internal energy, or you can power a cog-free generator that powers a facility or some other device. What is coming up next is Channel 9 explaining how Australia is reversing the grid with excess energy that we are adopting with OEMP, period.
While politicians argue about the future of our energy systems, it may have already arrived. A new Ausgrid trial is allowing solar customers with battery storage systems to sell their excess energy back into the grid and actually make money.
With a growing family, Johnson and Grace Lee are interested in the health of the planet as well as their finances. They have solar panels and a battery storage system, and it's paying off.
My electricity bills are quite low and at times close to zero.
They're part of Ausgrid and Reposit's virtual power plant trial. More than 200 customers across Sydney and the Central Coast are letting their power leftovers make the electricity grid more reliable for everyone else.
A battery in a house like this will provide power to the house during a blackout, but before that occurs, hopefully that battery has been able to be used by Ausgrid to stop the blackout from occurring at all.
When Ausgrid needs more energy in the system, it will send a ping to customers' batteries using the Reposit software. The excess energy stored in those batteries is then exported to the grid, where it can be accessed by other users. Reposit then pays its battery customers for the energy they supply, up to $135 a year, depending on the size of their battery.
It means our costs are lower across the board and everyone accesses a bit of renewables.
To be part of the trial, you have to own a solar battery system. There are plenty on the market, but the starting price is around $10,000, which means this isn't for everyone. But there are other incentives.
I wanted to be more self-reliant on my own energy sources.
If successful, this trial could provide a cheaper alternative to other investment in the electricity grid. Jane Azapati, 9 News.
Once installed in facilities or homes, OEM Power is able to reduce the amount of solar and wind turbines to power your home. Plus, if the power goes out, you're okay. ITNN 2020, reducing renewable costs with off-energy micro power. Why not power real estate that already exists with OEM Power, your home? Saves a majority of your energy costs, which becomes disposable income in a few years. As mentioned earlier, reduces dependencies on renewables such as solar and wind turbines. ITNN reporting OEMP's ROI on investment next. Once installed, you're off the grid and your energy savings pays for the machine for the next 6 to 9 years. If you reverse the grid with your energy company, then your ROI could be around a year.